Okay, when we're solving quadratic equations, this is going to be a long, extensive video, probably close to 20 minutes, but it's going to go over all the different nuances of solving a quadratic. First, when we're doing this, we need to make sure that we've expanded and collected like terms for the equation that we're looking at, and we've also put everything on one side. We want to make sure that the equation is equal to 0. The second thing we want to consider is that we've set it up in the form ax squared plus bx plus c equals 0 because we want to be able to factor it if possible. That should be always the first way you look to solve the quadratic, but if you can't do that, you can always complete the square and solve, which is not a common way of doing it, but it's not always difficult. And then finally, you would use the quadratic formula if you're unsure of any other way to do it. This first one, it says factor and solve. So the first thing we're going to look at is we're going to put everything onto one side of the equation. And then we're simply going to factor. But if you were to look at this, you would recognize that we need to change the signs here because otherwise it's actually not going to work. So when we were putting this together, obviously we made that mistake. But now when we look at this, we can have x plus 2, x plus 1 equals 0. That's the only way to factor it. And then we would get x equals -2 or x equals to -1. Okay, we're creating this bracket equaling 0 or this bracket equaling 0. We're finding the roots of this equation. Okay, the other thing you could do is if we had something like this, you can complete the square to solve the equation. Now, completing the square involves obviously a little bit of math, a little bit of know-how, but it's not overly difficult. Okay, so the first step, we're always going to factor out the a value from our first two terms. Then we're going to take half of our b value, or our new b value, and square it because we want to create a square. So we get 2.25 minus 13. And if I've added that 2.25, really what I've added, I'm just going to put a mark in here. I've actually added 4.5 because 2 times 2.25 is 4.5. And I need to remember that if I were to expand that out, that's what I've added in. So I need to subtract that outside here, equals 0. So then we've got 2 and we've got x minus 1.5 squared minus 17.5 equals 0. And now to solve, we simply have to move everything to the other side and start solving. So we're going to start by having 2x minus 1.5 squared equals 17. I'm doing reverse BEDMAS here to solve for x. And then I'm going to divide by 2. So I'll get x minus 1.5 squared equals 8.75. Now I'm going to just move over here. I'm going to get x minus 1.5 equals the square root of 8.75. Now, if you were to square root 8.75, you're going to get a big decimal, 2.95, something like that. I'm just going to leave it as the square root of 8.75. So when we look at that, we're going to actually have a plus or a minus. So then we're going to have x equals 1.5 plus or minus 8.75. Okay, so when we're running through that, that would be our final answer. We would have x equals 1.5 plus the square root of 8.75 and x equals 1.5 minus the square root of 8.75. And that's how we would solve by completing the square. Okay, so moving on. If we had a question like this, first step is to collect like terms and put everything onto one side. So we've got x squared. Now I need to move the 2x over, so I'm going to have plus x, and then minus 2 equals 0. I've moved everything to the left. I just collected like terms. Next step would be to factor. Now this is a simple or easy trinomial. We get x plus 2 and x minus 1 equals 0. And then we're going to get x equals -2 or x equals 1. and we're all done. Okay, that's all there is to it. This one a little bit harder, but really this one's just harder because becomes a tricky or a difficult trinomial. There's not actually a lot to this question. You just need to recognize how to factor it. Okay, so if I looked at this, we can see that we have a positive c value but a negative b. So what that means is that both of my finishing terms or last terms in the binomials are going to have to be negative. Now I'm going to make it -1 and -4, and then we're going to have 4m and m. Now if you wanted to check to see if you were right, we would do 4 times 4 is 16, and then add it with 1 times m, which would be 17, and that's our middle term. And because both of these are negative, we know we're correct. We'd get -17. So going through that then, we're going to have this is equal to 0, and then we're going to get m equals 1 over 4, or m equals 4. Okay, just a little bit harder trinomial to solve, but still all of the same steps. Looking at a question like this one. Okay, we've got 4m squared, and that should be an m, or we could change this whole thing to an x, it doesn't matter. We get 4m squared minus 8m plus 1 equals 0. Now for this one, we can't factor it. Okay, so let's look at what it would be if we use quadratic formula. So I'll write out the quadratic formula, this first one, but we've got it on our formula sheet and we have it at the first page of this note, so I'm not going to write it out every time. Now we need to remember that this is in ax squared plus bx plus c. Okay, we've changed it to that form always. So our a is always our first term. Our b in this case is -8. So we would have -8, which is +8, plus or minus the square root of b squared, which would be -8 squared, minus 4 times 4 times 1, all over 2 times 4. So then we're going to get 8 plus or minus. Now in the bracket there, we've got 64 minus 16. So we're going to get 48 over 8. Now 48 divides by 16. So this would become 8 plus or minus the square root of 16 is 4. And we could have root 3 over 8. And that would be fine for a solution. Some of your calculators will actually take it a step further for you. So if you got to this step, that's fine. You could reduce this down to, we could get it to be 1 plus or minus a half root 3. Or you could divide everything by 4 and you would get 2 plus or minus root 3 all divided by 2. And that would be fine as well. Okay, let's look at the next one. The next one's a little bit harder again, but only because there's a bunch of work we need to do first. Okay, so when I'm doing this one, we need to expand everything out and then simplify. So I'm going to do it in a few steps. I'm going to take my time. I'm going to expand out this binomial. So we get x squared minus 2x plus 1 equals, now I'm going to multiply this through. So 2x squared minus 6x plus 3x plus 7. Then I'm going to multiply this through, so we get 4x squared minus 8x plus 4 equals 2x squared minus 3x plus 7. Kind of simplified a little bit there. And now we're going to put everything on one side. I'm going to put it all on the left because we've got a bigger term there. So we get 2x squared minus 11x, and then minus 3 equals 0. Oh, that middle term shouldn't be 11 because we're moving that to the other side. It should be minus 5x, And that'll actually make this way easier. So now we can actually factor this. We get 2x plus 1 and x minus 3 equals 0. Again, we can check if we want to by doing 2 times negative 3 is negative 6, plus 1 would give me negative 5. So then I know I'm right. Okay, so moving through, then we're going to get x equals negative a half or x equals 3. Okay, again, to find those values, I'm just making this fraction equal to 0 or making this fraction equal to 0. Okay, so moving on. Got this one here, which is a little bit more difficult because we need to clear out our fractions. Now, if you really wanted to, I guess you wouldn't have to. You could use fractions, but it's just going to make everything a little bit harder. So if I was looking at this question, what I would actually consider doing is multiplying each term by 6, a common denominator, to get rid of my fractions. So that would leave me with 2w squared minus 3 equals 2w. And now I can make it 2w squared minus 2w minus 3 equals 0. So with that, you can't factor this. You're going to end up with a weird number. So what we'll do is we'll do the quadratic formula. You could solve, I guess, if you wanted to by completing the square. It's not going to be a nice number. So we'll just do quadratic formula. So we would get w equals, again, negative b, negative negative is going to be a positive. So we get 2 plus or minus, and then we're going to have the square root of negative 2 squared minus 4 times 2 times negative 3, all divided by 2 times 2. Okay, so that's going to leave us with 2 plus or minus. Now, 2 squared is 4, and we've got 4 times 2, which is 8, times negative 3, which is going to be positive 24. So we're going to get the square root of 28, all divided by 4. Okay, now, when we're doing that, you can, again, you can reduce this down. Some calculators will do it for you, some will not. So we would get 2 plus or minus, we'd have the square root of 4 times the square root of 7, which is 2 root 7 over 4. Now this is going to give us 1 plus or minus root 7 over 2. Okay, not a super easy question to do, but we get our answer. Again, depending on what we're doing, this is a suitable answer, or even this would be a suitable answer, because we're not testing whether or not you have the right calculator. We want to see that you can do the concept and get the solution. Okay, looking at this next question, there's a bunch of things about this that kind of make it difficult. It's not super hard, but first, if you recognize, you actually can't do this question the way it's written. So if we were to factor a 5 or even divide a 5 out, now I always encourage my students to factor it rather than dividing, because later in questions and in harder questions, if you divide that 5 out, you're going to be missing solutions, especially if you divide out one of the variables. That's really going to mess you up. So I encourage you to just factor it out. It isn't necessary in this case, but a lot of the times down the road it is. And for things like the a value or what our quadratic in this case, or whatever function we're looking at looks like, it's useful to have that value there. The way this is though, this would be a sum of squares and we can't actually do anything. So we'd be all done here. But if we were to change this to 5m squared minus 80 equals 0, we'd get 5m squared minus 16 equals 0. And then there's two ways to solve it from here. Okay, now we can divide that 5 out because really we're just trying to solve for our variable. So in this case, we'd then get m squared minus 16 equals 0 because 0 divided by 5 is 0. Then we'd get m squared equals 16, and then m equals the square root of 16. But because we've added that square root in, we need to have the plus or minus. And a lot of the times it's actually easier if we just factor those, if we recognize that that's a difference of squares and we just factor it, it's actually going to show us the plus or minus right there. We'd get m equals 4 or m equals negative 4. Okay? Same thing as having plus or minus the square root of 16 because the square root of 16 is 4. All right. So a couple word problems and then you can work on the practice. Okay, so a number and its square differ by 42. So what we want to look at here is when we have a number and its square, we want to say let x be the number. Okay, we're not trying to get fancy with our let statement. We're not trying to add any extra things in. We're saying exactly what x is. Some teachers will tell you to say let x represent the number or the first number. In this case, we just have a number. Okay, we know that they differ by 42. So if I said x squared plus minus x, that should equal 42. The number and its square have to be different by 42. So if I minus the square and the number, I should get 42. So then, if I bring that 42 over, we're going to get something like this. Then we can factor it. We get x minus 7, x plus 6 equals 0, and then x equals 7 or x equals negative 6. Therefore, the number is 7 or negative 6. We need to include both because both are possible. Okay, 7 squared is 49. 49 minus 7 is 42. 6 squared, or negative 6 squared, excuse me, is 36. And negative 6 minus 42, or sorry, negative 6 minus 36 is also 42. It would be negative, but it's still different by 42. So you need to include them both. Looking at this last example, we've got two sides of a perpendicular triangle, or sorry, a right angle of a perpendicular. So we've got our triangle. We've got a right angle triangle. The two perpendicular sides are 2x plus 1 and 2x plus 1. And then the other side is 3x plus 3. Find the length of x. So if I was looking at this, normally we would say a squared plus b squared equals c squared. To relate all three sides, we're going to use Pythagorean theorem. We know that this could be a or this could be a, and it doesn't really matter which one we make a, but this just has to be c. We'll call that b. But in this case, a and b are equal to each other. So really what we have is 2a squared equals c squared. Okay, if we have 2a squared equals c squared, we can do 2 times 2x plus 1 squared equals 3x plus 3 squared. Now, if we're going through that, we're going to have to expand and simplify. So I'm going to just zoom in so I can write a little smaller. So we get 2 times, this is going to be 4x squared plus 4x plus 1 equals 9x squared plus 18x plus 9. Okay, I don't know why I put brackets there, but I did. And then that's going to be 8x squared plus 8x plus 2 equals 9x squared plus 18x plus 9. Now, if we move everything to the right, just because it's easier, we'd get 0 equals x squared plus 10x. And then we have to minus that 2 over, so we're going to get plus 7. Now that doesn't work out all that nicely, so we're gonna have to use the quadratic formula again, or we could use difference of squares if we really want to. It doesn't really matter how you wanna do it. You can do it, or sorry, not difference of squares, completing the square, I should say. You can do it any way you want. I'm not a huge fan of completing the square, so I'm gonna just do the quadratic formula. This doesn't factor. So I'm going to just say x equals negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 7, all divided by 2 times 1. And then we're going to end up with negative 10 plus or minus the square root. And we've got in the brackets there, we have 100 minus 28. So we're going to get the square root of 72 all divided by 2. So then we get x equals, and we're just using negative 10 plus or minus, and we'd end up with 72, which you can divide by 36. Okay, so I'm looking for a perfect square. Each time when I had these square roots, I was always looking for a perfect square. So 36 times 2, so I would get 6 root 2 all over 2, which ends up being negative 5 plus or minus 3 root 2. So therefore, x equals negative 5 plus 3 root 2, or x equals negative 5 minus 3 root 2. Okay, we didn't have to do a let statement in this situation because the x's were already in the question, but we did use Pythagorean theorem, so I stated it at the start. You can work on the questions assigned for this now.